We will talk about the contiguous array problem. So this will be very iterative, where we'll discuss the solution, look at if it will work or will not work, how can we make it work, and how can we make it more efficient. So let's get started. So we're given a binary array and we have to find the maximum length of the contiguous subarray with equal number of zeros and ones. So let me simplify this question for you. So what if you were given an array and you had to find the maximum length for which there were equal number of zeros and ones starting at index 0, right? So let's think of it like this way. So we think of 0 as -1 and 1 as 1. Okay, and as we iterate through the array, we keep a count. Okay, and we add +1 to it when we see a 1, and -1 to it when we see a 0. And we store the value of the count at each index in this T-map. Okay, so like if we had the array 0, 1, 0, the T-map would contain -1, 0, 1. And the answer to this, the longest subarray, would be just the last index at which we have a count of 0 plus 1, because index starts at 0. So this works for when the array starts at index, when the solution starts at index 0. So can we make it so that we can incorporate solution starting at index 1, index 2, index 3, right? So we can do that. So we would use the brute force method, where we have two loops, and it's doing the same logic as we discussed above. We have an apps max that finds at each subarray index the max, and we return the max value. I will leave it up to you to make it better and think about it, but I just wanted to get to the better way of doing it. So when we have the brute force solution, but when we try to run it, it's gonna time out, and so we're trying to make it better. So first question is, can we make it better? Obviously. Not obvious though, but yes, we can make it better. So we question ourselves, how can we make this better, right? So for that, let us think about what was your intuition behind the 0. So for me, the 0 was an arbitrary equilibrium that I wanted to achieve. So like if you think about it, in chemistry, we have these electronic weighing machines, and to find the weight of a compound, first I take the container, tear it, and then add the compound and weigh it, right? So by tearing makes my 0 whatever the value was of the container. So in this case, if we visualize this array 0, 1, 0, 0, 0, 1, 0, 1, okay, so supposedly we if we start at 0, then our very first solution will work. But now when we started the second position, that is index 1, our count will already have a value of -1 that is coming from the 0 here. So for index equals to 1, in this case, our equilibrium is at -1. Can you imagine that? Take some time to visualize it. So if you see, the count already has a value of -1 at this position, and it's like you tear it, so we think of -1 as the 0 value. Okay, so how are we going to go about solving this problem? So we are going to use a hash map that will store all the instances of counts and the indexes associated with that count. Okay, so once we have the count, we can find the max value simply by iterating through the hash map for each count. Okay, so we can do max value equals to max of the max value, or the last index minus the first index. Okay, so let's look at this solution. So it's something like this. So I have not talked about this, so let's not think about this right now. We have a max length and a count, and we enumerate through the nums, and whatever count is there, we add that index to that value associated with that key. The key is the count. Okay, and if you keep in mind the equilibrium that I was talking about, the max length would be just the max of the max length, or the last element minus the first element. This works because, as we can see, we're adding the index in a sorted order. So I can just do v -1 minus v0, but this is equivalent to saying the highest index minus the lowest index. Okay, so if we run that, it will fail. Why? Because if it will fail in the case when your subarray starts at index 0. So like if we take an example 1 0 1 1 0 0, so the answer would be the answer we expect is 6, like 0 1 1 1 0 0. So that's 3 4 5 6 elements. But if we didn't have this temp equals to an initial value of -1, we will get the last index to be 5 and the first index to be 1. Okay, let me write it down. So our count map, count equals to say 0, would look like a map value would be index 1 comma, so 1 -1 0 1 2 1 and 0. So the last index is 5, so it would be 5 minus 1 equals to 4. So thinking about this, so we have to think around the base case, right? When our solution starts at the first index that is 0. So to think around it, we can add this value to our map. 0 at 0 we add a -1. Why will this work? So when we do max value minus last index of minus min value will be -1, because that will be the first position, first index. So -1 will be 5 minus -1, that equals to 6. So I hope that makes sense and that helped you.